All right, so interval notation, and that we have an interval of values. An interval would mean it like starts somewhere and it goes all the way through something else. Like we've seen intervals before when you graph on a number line. Why is this not changing the color? When you graph on a number line, let's say this is a 3 and this is a 10. Graph on a number line, it goes between 3 and 10, including 3 and 10. Like that's an interval of numbers. If I were to graph 3, 4, 5, 6, if I were to just dots, that is not an interval of numbers. So we would use interval notation if we start and go all the way through, including all those decimals. That's when we use an interval. We will use parentheses instead of things like less than or greater than. And we will use brackets if we are meaning less than equal to or greater than equal to. So the brackets would include the value, parentheses would not include that value. Infinity does not have an endpoint. Like infinity goes on forever and ever and ever. So you can actually identify infinity. So infinity uses parentheses. When we type stuff with domain and range, well, we're going to type this stuff into our computer. Can't type infinity in the computer. So instead of infinity, we're going to use 2 lowercase o's. Okay? Like OO. Or negative O. That's negative infinity. All right? So positive infinity, you don't need a plus sign, just infinity, and then negative infinity when we go to type it in Canvas. Yay. So here's just a bunch of different examples of what it would look like. Like if we had here's a line where it was less than or equal to 6. There's a number line of that. Well, we would write that. We always write left to right. We always go left to right. We always go smallest to highest, least to greatest. That's right phrase. So we would start at negative infinity, and that would get a parenthesis, and it would go to 6, but since it can include 6, we would have a bracket. For this one right here, x is greater than 6. If we're here at 6, we would have an open circle, and it would be above. So the very first thing I come to on this number line is the number 6. So that's why I wrote it first. But it's not equal to, so we have a parenthesis. It goes all the way to infinity. Infinities always get parentheses. The bottom one, sometimes we have multiple pieces. And I can show you another example of multiple pieces. But sometimes we have multiple pieces. Like this one here says x does not equal 6. So here we have 6. And x does not equal 6. That means x is less than 6 and x is greater than 6, but it does not equal 6. So I kind of have 2 pieces there. Anytime we have more than one piece, we're going to have more than one interval. And we hold those together with the union symbol, which is a capital U. So if you have more than one piece, you're going to put more than one interval together, hold them together with a union symbol. You could have like 5 different pieces. They all have to be separated by U's. So graph the function, write the domain and range in interval notation. So this is a reciprocal function. And I know a lot of us have been using transformations, so I'm going to do this one with transformations. However, you literally could just plug in points and figure it out that way if that's what you prefer. But our next section after 1-3 is transformations, so I might as well just start doing it now. If you get stuck, you can either ask questions about transformations or just make a table. What you shouldn't be doing is using your graphing calculator to find the points. So if I'm using my parent function over x, I like to use -2, -1, a half, 0, a half, 1, 2, and I will get -a half, -1, -2. I will get undefined here, 2, 1, and a half. So that's my parent function. And since this 5 down here is part of the 1 over, it's in the denominator, that 5 is in the denominator, that is going to be a horizontal transformation. Anything in this denominator for this particular function will be a horizontal transformation. Anything horizontal is opposite sign, opposite operation. So where I have a plus 5 here, I actually am going to think about minus 5. And how I use that in my table is I am going to subtract 5 from all my x's because the x's are the horizontal ones. So I just take all my x's and subtract 5. Wait. Oh, I forgot a negative sign on that. That's why it's wrong. Oh. So I subtracted 5 from all my x's. And this plus 2, that is outside of the 1 over x function. It's kind of happening after we do 1 over x. That translates vertically. If it's outside of that 1 over x function, this is going to be a vertical transformation. And vertical transformations just use the same sign. So we're just going to add 2 to all my vertical numbers. So I'm going to add 2 to negative 2. It's 1.5. 1, 0. I cannot add 2 to undefined. It is still undefined if I add 2 to undefined. There's one more piece of information that, unless you have studied these more, you might not know about, especially if you were CP last year and we skipped it. These reciprocal functions have 2 asymptotes. They always have the asymptote here, which is in the table as 0, x equals 0, undefined. But they also have a y asymptote, y equals 0. That's an asymptote. So when I go to add 2 to all the y values, this y value is something that I can add 2 to. I can add the number 2 onto it. So I will do that, and I will get y equals 2 as a new asymptote. So my asymptotes originally at 0 and 0, now they're moving, so they'll be at negative 5 and at positive 2. So that's where the asymptotes got moved to. And then we'll plot the new x's and new y's as ordered pairs. And I'm not going to give you any of these kind that are like super difficult. We will do these in a chapter. Oops, I put that spot, I think. There we go. We will do these in a chapter at some point, and that's when you'll get more difficult ones. Right now, we're just trying to worry about getting the basic shape graphed and talking about domain and range. So for domain and range, for these kind, where the asymptotes are, that's the only places it can't equal. So the asymptotes are really important because that's telling us our domain and range. So here, y equals 2, that's an asymptote. And up here, x equals negative 5. Those are our asymptotes. Okay, for the domain, x cannot equal negative 5. For the range, y cannot equal 2. Those are our asymptotes. That is not going to be how we write the domain and range anymore. We're going to write it in interval notation. So I have an example where I've done 6 in interval notation. But I'll just go ahead and write these answers for domain and range in the interval notation. So the graph itself is going all the way to negative infinity, and then it goes to -5, and that's where we have an asymptote. So I'm going to stop my first interval at -5 with a parenthesis, and I'm going to put a union. Then I'm going to start another parenthesis at -5, and I'm going to go all the way to infinity and close my parenthesis. So that's basically telling me we've got two pieces, but -5 is not included. There's no brackets, so -5 is not included. And then for the range, it's the same way. We've got two pieces up and down. The y is -infinity to 2, union 2 to infinity. So anytime you do these reciprocal functions, this is what your domain and range will look like. You just have to find those. The next one is square root. My original square root parent function points. I use 0, 1, 4, 9. Sometimes I use 16. It just depends on what happens to the numbers, if it'll fit on the graph or not. Yeah, that one. Okay. And then that'll give me 0, 1, 2, 3. And anything horizontal is opposite operation. Opposite. And because it's opposite operation, I'm going to add 4 to all my x values. And why did I do it to the x's? Because it's inside, but why did I do it to the x's? Because the x, when it's inside, it's what? Horizontal, and that's the direction x goes, horizontal. We gotcha. All right, so we got 4, 5, 8. That one's even off the graph. 0, 5, 1, 8, 2, and then the other one's way off the graph. But really, I'm just using this to practice graphing, but also to find our domain and range. So from left to right, does it go all the way to the left? Does not. So if I'm looking from left to right, my graph doesn't even start till the number 4, but it does include 4. So I'm going to make 4 a bracket because it includes 4. And then it goes all the way to the right. Was I saying my directions wrong? I kind of feel like I was. Anyway, I'm going to go all the way to the right to positive infinity. So it starts at 4, goes to infinity. The y, same kind of thing. We're going to go all the way down to 0, but it does include 0. And then we're going to go all the way up to positive infinity. So when you have square root graphs, they're going to have a bracket and a parenthesis, depending on which you're facing. Quadratic. So I'll start with my parent function points. And then if you remember transformations from before, this will go a lot faster. If not, I'm still walking you through them. This negative and this +1 are both on the outside of being squared, so both of them are vertical. It's almost time. So I will take on the y side, I will have to do 2 separate things, but we follow order of operations. So you will multiply by -1 first, and then you will add 1. I will, I'll probably just stay while you guys go to lunch. I'll probably just finish these notes so I have a complete video for you if you want to go back and watch it. There is a worksheet to finish for your assignment. Make sure you go on and see how I want it uploaded. It won't be due till it won't be graded till Wednesday because I've got 2 classes, so you guys get that extra day. But you should definitely have it done by next time I see you Tuesday, even if you just have questions. Okay? Okay, so we are taking this -1 that is being multiplied by x squared, and because it is out of the x squared, we are going to multiply all of the y values by -1. And then after that, we have a +1, and again, that's vertical. So we will add 1 to all of the y values. Okay, and then we will graph our outermost x and our outermost y. And my stylus stopped working. Okay, sorry about that. I'm going to graph my quadratic, that parabola shape. Now, our domain is how far to the left, how far to the right. All quadratics have the same domain. It's all real numbers. But we're going to write that beginning with -infinity, going all the way to +infinity with parentheses because it can never equal infinity. Now our range goes all the way down, So we're going to begin with -infinity. We always want to start with a lower number. And then it's going to go up, and it stops there at when y equals 1. So we can equal 1. It is included. We're going to use a bracket. Okay, question D is also quadratic. Another way of doing quadratics with transformations is if there's no stretch, I don't even really need to use the table. If there's no stretch and I know my points, my parent function points, I know like the pattern that they make, like from the center it goes out 1, up 1, out 2, up 4, out 3, up 9. If we know that squared pattern, I just think about where those points are, and then I know what my transformations are. This is going to be a horizontal transformation as it is inside of the squared, and the squared is the kind of function it is. So this will do opposite. It'll be a -5 to the y's. And then the +3 is outside of the squared. Sorry, I said plus, I meant -3. So that will be a -3 to the y's. The x's change the operation, the y's keep the same operation. So all of these points, I'm just going to move 5 to the left, and then 3 down. And then I'm going to recreate that exact same parabola right there, which since I know my pattern, it's pretty quick to recreate that pattern, that parabola. So we're doing this assignment to practice our graphing, but also to learn about interval notation for domain and range. So domain is all real numbers. That'll be from -infinity to +infinity. And the range goes from down to up. Well, this parabola goes down to -3. But then it goes up from there. So we are going to start at -3, and it does include it, and we go to +infinity. All right, the last one is a square root. And there's lots of transformations for this square root, so I'll go through all those transformations. Let me just get the square root points to start. All right, anything underneath the square root symbol is a horizontal transformation. So this is multiplying by -1. So instead, we're going to divide by -1. But I don't really like prefer dividing ever. So we'll just change dividing by -1 into a multiplying by -1 because they are the exact same thing. Now if it was a different number, you know, I might have to multiply by something else, but since dividing and multiplying by -1 are the same thing, I just like to multiply. Now, after that, we have a -2 inside. And again, that's under the square root, so it's part of that function. It goes on the x side, goes on the input side, but we do the opposite, so we're going to be adding 2. Now, why did I choose to multiply before I added? Because of order of operations. On the other side, we have a negative that is multiplied on the outside of the function, and we have subtract 1 on the outside of the function. So both of those are vertical, and we will do the multiply by -1 first, and this time we do the same operation, and then subtract 1. Oh, I did not make that a negative. All right, then I'm going to subtract 1. And when we go to graph, we're going to graph the outermost x and y's. So 2, -1, 1, -2, -2, -3, -7, -4. So if I talk about transformations, this one had a reflection in the y-axis, a reflection in the x-axis. We translated 2 units to the left and 1 unit down. So it had a lot going on. That's why it kind of has that way different shape than we're used to. I mean, not shape, but like turned a different direction. So domain are the x's. So if we go from left to right, the arrow tells me it's going to -infinity. And then it goes all the way to +2 before it stops, and it includes +2. The range goes from down to up. So I'm going to look over here. There's nothing stopping it from going down. So we will go all the way down to -infinity. And then after we go to -infinity, it goes all the way up to where y is -1. And it does include that -1. So that will be our function notation. Be careful when you do your assignment. There is one question in your assignment that you cannot write in interval notation. If you can't write it in interval notation, then write it the way we were writing it prior to this lesson. Okay, enjoy and have a great day.